Ladies and gentlemen, it is my pleasure to introduce our group TrailBlazers. We are information security and assurance students and have come together to tackle one of the most pressing issues facing the digital world today. Please join me in welcoming our esteemed members, myself Michael Muka, Tapiwa Kasazera, and Otita Mutants Wan Tawanda and Daba. We are presenting groundbreaking solutions on how to identify and remove harmful or illegal content without compromising user privacy. As the internet is now a primary source of information, the challenge lies in striking a balance between protecting users' rights to privacy and ensuring that the internet remains a safe space for all. From fake news to hate speech, cyberbullying to child exploitation, harmful content is rampant on the internet. While it's easy to identify some of these issues, others are more subtle and require advanced technology and expertise to detect. But even when harmful content is identified, removing it can be a daunting task. Many platforms have policies in place that prohibit certain types of content, but enforcing these policies can be tricky. For example, removing content that violates policies may require access to user data or communication records, which could compromise user privacy. So how do we strike a balance between protecting users' privacy and removing harmful or illegal content? It's a complex issue that requires collaboration between tech companies, policymakers, and civil society organizations. This challenge has led to innovative solutions by governments and technology companies. For instance, in 2019, the Zimbabwean government shut down the internet to curb the spread of false information and incitement to violence. In this video, we discuss ways to address this issue without compromising fundamental rights such as privacy and free speech. Our aim is to create a safer and more responsible internet for everyone. I am going to focus on our first solution, that is using a multifaceted strategy which can help prevent the spread of harmful content while also enabling privacy and security. Multifaceted strategy involves using multiple approaches to address a complex problem or achieve a complex goal, recognizing that a single approach is often insufficient. This strategy is the one that involves a range of stakeholders, including government, tech companies, and individual users, working together to create a safer and more secure online environment. For government, regulation is another important aspect of a multifaceted strategy. Postal and Telecommunication Regulatory Authority of Zimbabwe can pass laws that can require social media platforms and search engines to remove harmful content or face penalties. They can work with tech companies to disclose how they collect and use users' data. At the same time, Zimbabwe's Data Protection Act provides guidelines on how personal data should be collected and processed by social media platforms while protecting individual rights. This ensures that users' personal information is not misused by companies or third parties. Another aspect of this strategy is education. Educating individuals on how to identify harmful content and how to protect their privacy and security online is crucial. Let's look at our second solution, which is the use of machine learning algorithm. It has the potential to play a crucial role in preventing the spread of harmful content while also enabling privacy and security. This approach allows multiple devices to collaboratively train a machine learning model without sharing any raw data. Each device trains the model on its own local data and only shares the updated model parameters with a central server. This way, user privacy is preserved while still allowing for pattern detection. We also have homomorphic encryption, which is an encryption that allows computations to be performed on ciphertext, without the need for decryption. This means that data can be processed and analyzed without ever being exposed in its raw form, making it a valuable tool for end-to-end encrypted areas. This means that sensitive data can be kept private and secure while still being processed by machine learning algorithms. It can be used to securely share data between different organizations or entities. For example, tech companies could share encrypted data with the government for analysis without revealing individual user information. A realistic example of where homomorphic encryption should be used in Zimbabwe could be in the healthcare sector. Zimbabwe has a lot of patients suffering from diseases, with an estimated 1.3 million people living with the virus. In order to provide effective treatment and care, healthcare providers need access to patient data such as viral load and CD4 counts. However, this sensitive information must be kept confidential to protect patient privacy. Homomorphic encryption could allow for this data to be securely analyzed without ever being decrypted. For example, a machine learning algorithm could be trained on encrypted patient data to predict which patients are at risk of treatment failure or disease progression. The algorithm would never have access to the raw data, but would still be able to make accurate predictions based on the encrypted information. This would allow healthcare providers to make more informed decisions about patient care while maintaining confidentiality and privacy. Homomorphic encryption could also be used in other areas such as finance and education where sensitive data needs to be analyzed securely. Overall, homomorphic encryption has the potential to enable more effective and secure machine learning applications for preventing the spread of harmful content while protecting user privacy.